Have you guys seen all the flat earthers out there across social media? Just about every social media platform has got flat earthers posting videos of their little experiments, their little findings, trying to prove that the earth is flat. Well, surprise, it's not. So I'm going to do a 10-part video series explaining how the earth is not flat and how we can prove with common sense that it is really a sphere like we claim it is. So I've picked 10 big topics you can see here on the screen: the curve, the northern and southern stars, daylight, face of the moon phases, eclipses, distances, international flights, meteor showers in the zodiac, and Antarctica. 10 hot topics that flat earthers love to talk about. Let's dive into them one at a time, starting with the curve. So one of the most common videos that flat earthers post is challenging the curve because Earth is so huge, it is very hard. There's several ways to prove it, but not real easy when you're just standing on Earth and you're just a little being on this giant ball. It's kind of tough, and flat earthers pick at that weakness to prove their point that the Earth is flat. But as you'll see through this 10-part series, I will clearly prove the Earth is a sphere with common sense and what we can see with our own eyes, and there's no way to disprove it. Now, I love a good conspiracy just like the next guy. And honestly, I would love it if the Earth was proven to be flat. I would think that would be so cool that, hey, we challenged authority. We truly proved that it was flat. They've been lying to us. I would love that. So it's not like I'm completely against it. I just know that it's not true. So let's jump into one simple experiment that flat earthers love: the horizon on the water. So the picture on the left is just looking out at the ocean, and you see the horizon line between the water and the sky. And then they zoom in, and oh, lo and behold, there's a ship right there. So that proves it. The earth is flat. You can't see it on the left, but when we zoom in, there it is. Well, guess what? Fact number one: the ocean's horizon is only 3 to 8 miles away. That distance is nothing before it starts getting out of our view, going over the curve, getting lost in the haze and the evaporation off of the surface of the ocean. We can only see 3 to 8 miles. So that ship that they zoomed into is not very far at all. So let's talk about just the sheer size of Earth. It's roughly 8,000 miles in diameter. So you look at the two lines near the bottom, those are 8 miles apart. It looks like one line because they're so close together. So let's zoom into it. There you go. That's 8 miles. So the tests that I've seen, the 3 mile, 5 mile, 8 mile, maybe a 10 mile experiment, there's just no curve to be measured because the Earth is that big. The curve over 3 to 8 miles is barely measurable. So this video that we've seen several times, several different places, kind of the same basic idea of zooming in on a ship right there. It's at the most 8 miles away. There's just not going to be a curve to be seen. So that proves nothing. Fact number two: outer space, what we call it, is really only about 200 miles up. The International Space Station travels around the Earth at about 200 to 250 miles up. That's that little bitty speck on top of the globe here on my picture is about 200 miles up. The bigger picture on the bottom zooms in, it shows you about how far that is. So yeah, if you want to see the full globe from the International Space Station, they do use a fisheye lens to back up so you can take more in and see more of Earth. A lot of the mapping, the geo mapping, is done that way, where they take pictures going around the Earth and then they puzzle it all together. But what if there was something further out that could take a picture of Earth? Well, I'm glad you asked. Weather and communication satellites are about 22,000 miles above the surface of the Earth. So it looks about like this. This is about how far out they are. But then you ask, well, if those are circling around us, getting the weather and communication, direct TV satellites are up there like that far away, 22,000 miles up. Why don't they ever look back and take a picture of Earth? Well, they do. Here's two pictures here. The one on the left is from the United States GOES satellite. The one on the right is from Europe's MSG-3 satellite. The one on the left here is from Japan's Himawari-8 satellite. And the one on the right is from Russia's Electro-L satellite. Pretty impressive pictures of the globe, I would say. Now, a lot of people do find pictures of the globe that have been assembled, and you see patterns of the clouds that are repeated. There's a lot of Photoshop going on, and there might be Photoshop or lenses to make the pictures better, but this is Earth, 4 different satellites, 4 different countries looking back at Earth, proving with a photograph that the Earth is a sphere. So if you want to see it for yourself, you can see a gallery of live photos of the Earth as a ball every 10 minutes. Take a screenshot of this web address right here, and you'll see every 10 minutes there's a snapshot of Earth as the GOS satellite is traveling around Earth along with it. It's called I think it's geopositioning or geocentric. I'm not sure of the exact word, but the satellite travels at the speed that the Earth is spinning. So it's like it's stationary, staying in one spot. So the USA satellite is traveling along with USA. Japan is traveling with Japan. Europe's traveling with Europe, and so on. Those are satellites that look like they're not spinning, but they're spinning at the same speed of the spin of Earth, just FYI. And something kind of cool, if you want to see a live streaming flyover of Earth live over and over and over as the ISS circles Earth, you can go to the YouTube video here and watch it live anytime you want. Now, sometimes there are communication interruptions. If you go there and it's not displaying, you can just check back in an hour and you'll see it. But 24/7, you can see live streaming of Earth from the ISS. Now, it's a little bit closer to Earth than the weather satellites are, but you can see a clear picture how it travels over. And no, it's not continually turning left like a NASCAR race, like if it were going around flat Earth. It's staying straight, going around the Earth. Fact number 3, talking about the curve. Let's talk about sunsets. Sunsets happen when the sun disappears behind the curve of Earth towards the west. So this is kind of what that looks like. Now, the sun isn't that small and it's not that close to Earth, but it just gives you the idea. When Earth spins its back on the sun, half of the Earth is shaded and the other half is daylight. That's clearly proven with our day and night and our 24-hour day process, where 12 hours of night, 12 hours a day, roughly, as we spin our face and our back toward the sun. So when we're at night and the sunset happens, clearly you see these angles of the arrows pointing up. When we look across the horizon from wherever we are after sunset, we cannot see the sun at all. Yet on a flat Earth, let's check this out. What blocks our view of the sun after sunset on a flat Earth? So right here, this picture shows you the sun traveling in circles over a flat Earth. You see the lit up area, that's the flat Earth so-called day as it goes around. The people at the origin of that arrow, right now this map is on the eastern United States. So if you were in New York after sunset and you pointed a telescope up at the sun, there's nothing on a flat Earth obstructing your view of the sun. So if you want to do a test of the curve on a flat Earth, 1 hour after sunset, get your strongest telescope and try to find the sun. You can't. Even the strongest telescope on Earth cannot see the sun 1 hour past sunset. Game over for the curve.